Welcome to section 8.5, factoring special products, and this is the second video. This video is specific to essentially factoring the difference of two squares. So we're still dealing with trinomials, kind of, but we're actually looking at a trinomial that has a missing middle term, so it's no longer really a trinomial, it's kind of like a quadratic binomial, which is a little different than what we've been studying. So we have essentially factoring a difference of two squares. Essentially, something that is a difference of two squares, they have to have the same criteria. There needs to be two terms that are subtracting one another. That was not something I needed. That are subtracting. So essentially, one term needs to be subtracted from the other. The other factor that we need to pay attention to is both terms need to be perfect squares. Both terms need to be perfect squares. And if that is the case, we can essentially follow this roadmap right here. We have a squared minus b squared, so two terms, a squared and b squared, those are two different terms, and one's subtracting the other. And then both of our terms are perfect squares because they have this squared thing right here. Now you're not going to see that blatantly obvious in the problems that we're dealing with because you actually have to sort of deconstruct those numbers to really understand that they're perfect squares. But essentially, if we have that, we can write them as a plus b times a minus b. And that's what we're ultimately going for. Remember, we're going from having factors and going into what they would look like if we FOILed them into their polynomial form. And then we're going from the polynomial form and back into the factors. So we're learning how to go back and forth in between those two forms. So let's actually try a problem so we can see what I'm gibbering on about. We have x squared minus 81. And with this, we can see that both of these terms are technically squared numbers. X squared is essentially x times x, and 81, if we were to break that down, we have 9 times 9. And we're going to avoid looking at this minus sign except for the fact that we like that the subtraction sign is there. With the subtraction sign, we know that this is a difference of two squares. So let's actually try to figure out why this all works and what is going on here. So let's do bottoms up with this, and we need to put down a middle term. Well, before, our middle term, our middle coefficient, had an x next to it. And do you see an x in this situation? No, it's non-existent, so we put a 0 there. And so we need to have two numbers that'll add to be 0. And right on the bottom, we have negative 81. So now let's think about all the factors of 81. Let's break this thing down. We have 1, 3, does 6 go into 81? Nope. Does 7? Nope. How about 9? Yep, 9 goes in twice. And then 27, 3 times 27 equals 81, and 81. So those are all of our factors for 81. And if we're thinking about this, what two numbers are going to add or subtract of these numbers? What two numbers are going to add or subtract to be 81, or negative 80, or to be 0, and also multiply to be a negative 81? Well, a positive 9 and a negative 9 will do that trick for us. And 9 times 9 equals 81. So that's kind of cool. And we're going to put that all over 1, which is our first term. And now we're going to take this and do bottoms up with it. So bottoms up tells us the 1's going to go out in front. And then we're adding our 9 to it. And then same thing here. 1 will go out in front, minus 9. So there we go. We have 1x plus 9, 1x minus 9, and if we had actually paid attention to this roadmap right up here in the first place, we could have avoided all of this work right there. We could have just said, oh, well, here is my A term, here is my B term, I'm going to just put it in this roadmap, and that would be awesome. So let's actually do this and actually practice this. Here we go, here's our problem. We have p to the 4th minus 64r to the 6th. Now I know you're looking at this and thinking, how is p to the 4th potentially a squared number, and how is r to the 6th for sure a squared number? Because we know 6 isn't a squared number. Well, one thing we need to pay attention to is these are exponents. Exponents can break down sometimes in really interesting ways. So that p to the fourth, we can write that as p times p times p times p, or if we wanted to do it as squared numbers, we could also say, well, this is p squared times p squared. That's something I like. One thing we can also do over here is we can look at 64. So this 64, if we broke it down, we could say 64 is 8 times 8. And this r to the 6, we could break that down into r times r times r times r times r times r. Or, if we wanted to split it up like we did these p's, we could split it up into two sections of r. So we have r to the third times r to the third. Remember, when we're multiplying exponents, or when we're multiplying two numbers that have the same base and an exponent, we're just adding those exponents. So r to the third, or r to the sixth equals r to the third plus 3. All right, so now let's break this down and put it into this format of that a plus b, a minus b, and I'm just getting my template ready. So I'm getting that roadmap ready. To start out with, I'm going to put my a term in. So I'm going to put a p squared in, and I'm going to put it in on both sides. Might as well, right? So put it in on both sides, take care of those. And now I need to take care of my b term. I have an 8 that I have to deal with, and I'm going to put that on both sides. And then we have r to the third and r to the third. So now we're done technically. But let's check our work. Let's actually do FOIL on this and see if my math was correct. If we do FOIL, we can start out with our p terms, p times p, or p squared times p squared. We know that'll end up being p to the fourth power. We can then also do our outside terms, p squared minus r, or 8r to the third. We can write that as 8p squared r to the third. We can do our inside terms. We now have a positive 8p squared r to the third. And our last terms, 8 times 8 is 64. R to the third times r to the third is r to the sixth, and this is a positive times a negative, so it's a negative. If we look at all of this, we can look at these middle terms. They are going to totally disappear, cancel out, and all we have remaining is our first term, p to the fourth power minus 64r to the third. That is exactly what we started this, or r to the sixth, sorry. That is exactly what we started this problem out with. That's awesome. So that is our last bit of this video, section 8.5, factoring special products and doing difference of squares. I hope this helps and enjoy your math homework. Bye.